Keep on. Absolute extreme. Go down the review example here. So find all absolute extreme on the given interval. I'll give you a function. F of x equals square root of 4 minus x squared. I'll give you an interval, negative 2 to 1. So do you remember kind of our strategy for finding absolute extreme? What do we look at? Critical numbers. We're going to test critical numbers against endpoints and see where the highest point ends up. So how do you find critical numbers?
Set up the derivative equal to 0.
Take the derivative, set it to 0 or undefined. Okay, so first find critical numbers. So to do that, let me go ahead and rewrite f of x. I don't like square root. I would rather use 1/2 power. So then what's f prime going to be? 1/2 comes down. Inside stays the same, so 4 minus x squared to the negative 1/2. Right, don't forget to subtract 1. Times what?
Negative 2x.
Times the derivative of the inside, which is negative 2x. Clean this up a little bit. The negative 2x is going to stay on top, but on bottom I'm going to have a 2 and a root 4 minus x squared. So then these 2's cancel, and I have negative x over the square root of 4 minus x squared. Beautiful. So my critical numbers come from setting the derivative equal to 0 or figuring out where the derivative is undefined. So if I want to set my derivative to 0, what do I focus on?
X equals 0.
The numerator, right? A fraction can only be 0 if the numerator is 0. So you do negative x equals 0. Set your numerator to 0. And that gives you x equals 0 as one of your critical numbers. One critical number. Then I also have to worry about where f prime of x is undefined. So what am I going to do here? Yeah, undefined is going to happen when your denominator equals 0. So you have to figure out where square root of 4 minus x squared equals 0. Where's that? 2 and negative 2. Right, you're going to square to get rid of the square root. So 4 minus x squared has to equal 0. You move the x squared to the other side. Square root both sides. And you got plus or minus 2. So these are my critical numbers, but I'm only on the interval negative 2 to 1. So actually I don't care about the positive 2 solution because it's outside of my n. And in fact, the -2 solution was my endpoint anyway, so I had that already. But it's okay. So I got it. I got my critical numbers. What do I do with them?
Table.
Make a table, plug them in. So compare your critical numbers to your endpoints. Test. So I know -2 is an endpoint, I know 1's an endpoint, and then the only critical number in between is 0, because I already have -2 on my chart. So you plug them in to the original function. When you plug in -2, what do you get?
0.
0, right? 4 minus 4. -2 squared is 4. 4 minus 4. When you plug in 0, you get the square root of 4, which is 2. And when you plug in 1, you get the square root of 3, because it's simple. So what's your absolute max and absolute min? Absolute max. So absolute max is 0, 2, because that's your highest y value. And absolute min is -2, 0. You guys know what the graph of this is? Circle. Half. How do you know that? Because you've seen it so many times that you memorized the formula, hopefully. Right, you know x squared plus y squared equals 4 is a circle of radius 2. And when you solve this for y squared equals 4 minus x squared. And when you square root both sides, y equals plus or minus square root of 4 minus x squared. So this, the positive root is the top half of the circle, the negative root is the bottom half. Since I gave you the positive root here, this is the top half. But it's only on the interval -2 to 1. So here's -2, here's 1. I would have the top half of the circle like this, but I'm cutting this part off. So this is my graph. And that's why 0, 2 is my maximum up here. And then -2, 0 is my minimum. Makes sense. This is my point. Okay, so I'm going to give you another example. So find all absolute extrema, same instructions. On the but now the function is kind of funny. And I'm going to put you on the interval. So if I were going to, so if I were using my method, right, I would go through and find my critical numbers. So I would have to do f prime of x. Right, and to find f prime, I'll probably rewrite f as x to the -1. So f prime of x is equal to -x to -2. Or negative 1 over x squared. Yeah, so as far as f prime equals 0 goes, that's never a possibility, right? Because that would, you have to have the numerator equal to 0, and it doesn't ever. F prime undefined?
0.
Yeah, so technically f prime is undefined when x equals 0, right? You set the denominator equal to 0. Unfortunately, this is not in the domain of my original function. Right, if you plug 0 into the original function, you get 1 over 0, which is undefined. That's bad. Not in domain of f. So I can't use this to test anything because it doesn't make sense in the original function. So what you might think is, okay, well, I didn't get any critical numbers I can use, so let me just test the endpoints. You could do that. You could test. And if you plug them in, x, f of x, negative 1, 1. When you plug negative 1 into the original function, you get negative 1. When you plug 1 in, you get 1. So here's my question. What's the conclusion? Are we going to conclude that negative 1 is a minimum, and 1, 1 is a maximum?
No.
No, actually we don't. Why not?
Draw a graph.
Yeah, I mean, we're doing a bunch of calculus to try and figure out the absolute max and absolute min of this thing, but we know what this looks like, right? 1 over x is just this guy. Oh, wrong way. This guy. And I want to know the absolute maximum between negative 1 and 1. So when I plug in those points, I get 2 points. That's fine. But they're not, neither, I mean, it's not the absolute maximum or absolute minimum. Because it shoots, because the graph shoots off to infinity at 0. So what's the problem? It's discontinuous. The problem, the reason our calculus isn't working is because this function is discontinuous. Right? Everything we've been doing for absolute extrema depends on a continuous function. Otherwise the logic doesn't make sense. So because this is discontinuous on this interval, we can't use this method. If you have, see the problem, if you have a continuous function, it will always attain an absolute maximum or minimum, absolute maximum and minimum on a closed interval. Right, if you have a function, a continuous function, and you have a closed interval, that function has to go from this point, wherever it is, to this point, wherever it is, and it's going to, however it does it, it's going to end up with an absolute max and absolute min because you can't lift your pen. But as soon as you have a discontinuous function, you can lift your pen, and then you don't necessarily even have an absolute max and absolute min. So this kind of logic where you test the critical numbers and the endpoints doesn't hold water. Someone would mention that, so I don't think I made that clear last time. This is called the extreme value theorem, the theorem that says that every continuous function has an absolute max and absolute min on a closed limit. I don't really care if you know that or not, but I do care that if I give you 1 over x and I ask you for the absolute maximum, you tell me it doesn't have 1 because it's got an asymptote. You don't try to do calculus and make some bogus argument.